This is the recovery video for Unit 1, Logic and Reasoning. For the first 3 questions, we're going to write down the key points that we need to know for Unit 1 that will make it easier for us to answer the questions that follow. So the first question asks, what are the types of related conditional statements? So we are usually given the original conditional statement. And it's going to be in the form if P, then Q, which could be written in logic symbols, which is coming soon. P, arrow, Q. Now, what we're going to do is we're going to take this original statement and we're going to rearrange it to make different forms of it. And the first one that we learned about was called the converse. And for the converse, you're going to switch the P and the Q. And my little story for this one is this morning I woke up and I was so tired that I put my Converse sneakers on the wrong feet. I tried to walk down my stairs and it was very uncomfortable. Am I going to leave those Converse sneakers on the wrong feet? And my answer is no. I'm going to switch my Converse sneakers to the correct feet. So the key point here for converse, you're going to switch the hypothesis and the conclusion. All right, so instead of saying if P then Q, it's going to now say if Q then P. And in symbolic notation, that would look like Q, arrow, P. All right, the next related conditional is called the inverse. Now, the first 2 letters in this word tell me exactly what to do. I'm going to keep the P and the Q in the original order. And I'm going to, in the letter N, I'm going to negate each part. So, in if then form, my inverse would say if negated P, then negated Q. And in symbolic notation, that would say negated P, arrow, negated Q. All right, the next related conditional is called the contrapositive. The contrapositive is the longest of the related conditional words. That means I have to do everything to the P and the Q, the hypothesis and the conclusion. So I have to switch and negate the hypothesis and the conclusion. You've got to switch and negate both parts. Let's make sure I spell that right. Switch and negate the hypothesis and the conclusion. All right, so in if then form, it would say if negated Q, then negated P. I had to take the original, I had to switch the P and the Q, and I had negate the P and negate the Q. All right, and shortcut notation, it would say negated Q, arrow, negated P. Put this original one way up here at the top. We switched them and we negated each part. All right, last one is called the biconditional. It's not use a color that's too light. Now, y'all, bi means two. Okay, so the biconditional means we take out the word if, and we take out the then. And what we're going to do is we're going to insert the words if and only if in the middle. So in um, if then form, we would say P, if and only if Q. Now, that's an appropriate abbreviation for if and only if. If you want to write out the words, you can, but that's the little shortcut if you'd rather use the shortcut. Right? And in symbolic notation, it would be P double arrow Q. A, bi means two. So look, we take out two things. We replace it with a phrase that has two ifs in it. If we abbreviate with the appropriate abbreviation, it will have two F's in it. And if we write the biconditional in symbolic notation, it will have two arrows instead of just one. All right, now we're going to practice using some problems that use all of this information. But for now, I want you to pause this video and go write all of this in your math notebook. Number 2, what are the logic symbols? The first symbol we learned was this symbol, and that stands for and. The way I remember that stands for and is if I were to put that extra little line in there, that would look like the capital letter A. And just happens to start with the letter A. So just remember, it kind of looks like a capital A for and. The second symbol we learned was the V, and the V stands for or. Then we learned the squiggle. The squiggle means negate. And when you negate a phrase, you either add the word not or you take the word not out. It depends on what your original phrase was. Then we learned the three dots. That means therefore. The single arrow means if, then. And the double arrow means if and only if, whose abbreviation is appropriate as IFF. Question 3. What are the 4 laws for deductive reasoning? All right, all 4 laws begin if P, then Q. Now, if they all begin the same, then that part of the argument is not going to be very helpful for us to decide if a conclusion is valid or invalid. What really matters is statement number 2. All right, so for our first law, statement number 2 takes the hypothesis P and it repeats it. So it reminds me of Pikachu from Pokemon. PQ, PQ. Pikachu, Pikachu, PQ, PQ. I don't know, y'all. If you're a Pokemon fan, maybe that's going to help you remember the first law of deductive reasoning. Starts off if P, then Q. Then they tell you something about the hypothesis P. If that's the case, then your conclusion is going to be Q. Now, for the second law, we're going to take the P and the Q, and we're going to switch and negate for the contrapositive. We're going to switch these and negate them. So my second phrase is going to be negated Q. If that's the case, then my conclusion is going to be negated P. Look, we took the P and the Q, we switched them, and we negated each one. That's the second law of deductive reasoning. Now, the last two have two if-then statements. If P, then Q. And then the second statement's going to say if Q, then R. The Q's are going to cross out as long as one is at the end and the other one's at the beginning. So your first answer would be what's left in the order that they're left. If P, then R. The last law, the Q's are still going to cancel out as long as one is at the beginning and the other one is at the end. But what we're going to do for this one is we're going to take what's left and we're going to switch and negate them. So my answer here would be negated R, then negated P. All right, you should pause your video right now and make sure that you have the logic symbols for number 2 written in your math notebook. And you have the 4 laws for deductive reasoning written into your math notebook. Once you have those written down, then come back and we'll work these problems. Question 4. Using the statement below, match each related conditional with the correct description. If it is on sale, then I will buy it. The phrase, it is on sale, is P the hypothesis. I will buy it is Q the conclusion. A, if it is not on sale, then I will not buy it. All right, let's check carefully. It is not on sale relates to the original P. And you've got to decide, is it perfect P or is it negated P? The original said it is on sale. This one says it is not on sale. That is negated P. I will not buy it relates to the original Q. We have to decide, is it perfect Q or is it negated Q? I will buy it. I will not buy it. That's negated Q. If then I know is the single arrow. So for this one, when I compare to the original, it stayed in order, but each part was negated. All right, I've got to think back to my notes at the beginning. Number one, in order, negate each part. That would be the inverse. All right, so the first one here would be inverse. All right, and we're just going to do that for 2, 3, and 4. We're going to compare to the original and then determine what type of related conditional it is. All right, number 2. It is on sale if and only if I will buy it. All right, now don't check back to A, check back to the original. It is on sale. That is perfect P. If and only if, we'll decide about that in a minute. I will buy it. That is perfect Q. Now I see 2 ifs in here. And I'm remembering that 2, that prefix would be by. By means 2. Biconditional means if and only if. I have 2 of the ifs. That means I would have double arrows. So B is biconditional. Number 3, if I will buy it, then it is on sale. I will buy it is Q. I will buy it. I will buy it. That's perfect Q. It is on sale. It is on sale. That's perfect P. If, then is the single arrow. So how does this compare to the original? I see the P was originally the first part, and now it's at the end. Q was originally at the end, and now it's in the front. So I would say that my Q and my P switched places. Let's go back up and see which one is switch places. Here you go. If we switch the hypothesis and conclusion, that would be forming the converse. So I know that C, or number 3, is the converse. Right, and D, or number 4, if I will not buy it, then it is not on sale. All right, I will not buy it is related to the Q, but I've got to decide, is it perfect Q or is it negated Q? Let's check closer. I will buy it. I will not buy it. That would be negated Q. It is not on sale is related to the original P. But we have to check, is it perfect P or is it negated P? It is on sale. It is not on sale. Well, y'all, that's negated P. And finally, if then would be the single arrow. So for this one, the Q and the P switched places with each other, and each part was negated. So let's go up and look. Which one is it when we switch and negate each part? Here we go. Switch and negate would be contrapositive. So D, or number 4, is contrapositive. Number 5, given the statements, P, I am taking geometry, Q, I attend college, R, it is not Saturday. Create the statement represented by the symbolic notation squiggle R, V, Q. All right, so y'all, that squiggle really means negated R. So we need to go find the R phrase and we need to negate it. Right, so if it already has a not in there and we negate it, that means take the not out. So this first box would be, it is Saturday. All right, that's the best I'm going to be able to do, I think. I really want to make it fit in the box. There we go. That's a little bit better. All right, in the middle, we need to remember the word that would replace the V. The V represents or. So I'm going to put or in the middle box. And then I'm going to go get the phrase for Q, and I'm going to leave it just like it is. I'm not going to negate it. I'm going to leave it alone. Right, so let's see. Q is, I attend college. I'm going to put that in the box down here just like it is. So if we put that all together, it would say, it is Saturday, or I attend college. Question 6. Rewrite the following sentences in symbolic notation using P equals the baseball game was played and Q equals it rains today. All right, so wherever we see the words the baseball game was played, we're going to replace that with the letter P. Wherever we see it rains today, we're going to replace those words with the letter Q. First sentence, if it rains today, then the baseball game will not be played. It rains today, I see, is a perfect match to Q. So in the first box, I'm going to put Q. The middle box is for the symbol that we're going to use. We'll come back and take care of that in a minute. The last box is for the last part of our sentence. So we've got to match up. The baseball game will not be played. That's very much like the P that they gave us, except it has been negated. They put in that extra not that wasn't originally there. So the third box would be negated P. Now, finally, we need to figure out which symbol goes in place of if, then. Now would be a perfect time to look back in your notebook because we wrote down all the symbols that you needed for Unit 2. And I know that if then would be the single arrow. So sentence number 1 in symbol form would be Q arrow negated P. Second sentence, the game was played. Let's see, the baseball game was played, not just the game, the baseball game was played. The baseball game was played. That is a perfect match to P. So in box number 4, I'm going to put in P. And finally, therefore, it did not rain today. All right, we'll come back and take care of the symbol for therefore in a minute. Let's go ahead and take care of it did not rain today. Did that match up with the original P or the original Q? All right, let's see. Rains today, did not rain today. That would be negated Q. And the symbol for therefore would be the 3 dots. Question 7. Select which of the following statements provides a valid conclusion. Choose all that apply. All right, y'all, please go back and find your 4 laws of deductive reasoning. And what we have to do is diagram our arguments. If it matches one of the 4 laws, we're going to choose it to be valid. If it doesn't match one of our 4 laws, then we're going to identify that argument as invalid. All right, let's see what we have. A, if Paul wants to go to the movies, then he will need to earn money. All right, going to the movies is going to be P. Earning money is going to be Q. Paul didn't go to the movies. That relates to the P, except it was negated. Therefore, Paul didn't earn any money. Earning money was the original Q. It matches very closely, but it was negated. So y'all, the hard part's done. We've labeled our argument. Here's what it would look like if we put it all together. If P, then Q. Negated P came next. Therefore, negated Q. You just have to look back in your notebook to see, do any of our laws perfectly match this argument? All right, so I'm going to go back up and check out my laws. All right, here's one that looks similar, but our P and our Q were negated. That's not a perfect match. These are negated, but in different orders. So our argument does not match law 2 either. And y'all, we didn't have 2 if-then statements. So A does not match any of the laws. Therefore, that argument is invalid. They want the valid argument, so I know that's not the right answer. Let's see. They want valid. All right, so that's all we're going to do. We're going to label our arguments. You're going to go check in your notebook and see if it matches, and then we'll put the answer. All right, part B. If the fox sees the rabbit, then it will hunt. All right, so the fox sees the rabbit is P. It will hunt is Q. Second sentence. If the fox hunts, y'all, that repeats the Q. Then it will be happy. That's a brand new statement. That's going to be an R. Right, and our final statement. Therefore, if the fox sees the rabbit, that's P, then it will be happy, that's R. Right, so if we put that all together, it goes if P, then Q, if Q, then R, therefore, if P, then R. Right, look in your notebook and see, does this argument match any of the laws perfectly? Yes, it does. It matches the third law. So that would be a valid conclusion. All right, part C. If you study for the test is P, then you will get a good grade. Get a good grade is Q. You got a good grade. That's Q. Therefore, you studied for the test. That would be P. All right, let's see. What do we have here all together? The first one would be if P, then Q. Q, therefore, P. All right, look in your notebook and see if this matches any of the four laws. If it matches, you're going to put valid. If it does not match, you're going to choose invalid. Hopefully you saw that this does not match any of the four laws. It is an invalid conclusion or an invalid argument, so we are not going to choose C as one of our answers. All right, D, if Tommy oversleeps, P, then he will be late for school, Q. Tommy overslept, P. Therefore, Tommy is late for school, Q. All right, let's take a look at this one. If P, then Q, P, therefore, Q. All right, once again, go take a look at the laws you wrote down in your notebook and decide, does this argument match any of the laws? Y'all, this is the one that reminds me of Pikachu. Pikachu, Pikachu. PQ, PQ. That's the first law. Therefore, D is valid. All right, last one. Here we go. If Ringo wants to be in the band, P, then he needs to learn an instrument, Q. If Ringo learns to play the drums, y'all, that's not a perfect match, but we've got to kind of go out on a limb here. Aren't the drums a certain kind of instrument? So they're really telling us about Q again. They just put in a specific instrument that he wants to learn. Then he will annoy his parents. Well, that's brand new. That's going to be an R. Therefore, if Ringo doesn't want to be in the band, that would be negated P. Then he will not annoy his parents. That is negated R. So altogether, E would go if P, then Q, if Q, then R, therefore negated P implies negated R. This does not match any of the four laws. Therefore, E is not valid and is not one of our answers. The only two that would be valid would be choice B and choice D. All right, question number 8. Consider the true statements. If it is raining, then we can't play baseball. We can play baseball. Therefore, it is not raining. Right, this is just like the question we just did, where we have to mark all of our P's and Q's, and then just check to see, does it match one of our laws? All right, let's see. It's raining would be P. We can't play baseball would be Q. We can play baseball would be negated Q. Because look, this actually had a not in it to begin with, and then they took it out. Therefore, it is not raining. Not raining would be negated P. All right, so let's list it out. First sentence, if P, then Q. Negated Q. Therefore, negated P. Does this match any of your laws? Yes, this matches the second law. Therefore, this argument is valid. Question 9. Does statement 3 follow as a valid conclusion from statements 1 and 2? Y'all, this is just another way to say, is this a valid argument? So we're going to keep marking our P's and our Q's. All cats like to nap. Y'all, that statement can be rewritten in if-then form to say, if it is a cat, then it likes to nap. Okay, we learned how to turn an all statement into an if-then statement back in Unit 2. All right, so here we go. It is a cat would be P. It likes to nap would be Q. Statement 2. Paul's pet is not a cat. Okay, is a cat, is not a cat. That would be negated P. Therefore, it doesn't like to nap. Likes to nap, does not like to nap. That would be negated Q. All right, so it went if P, then Q, negated P, therefore negated Q. Check to see, does this match any of the laws? That does not match any of our laws, so this is an invalid conclusion to say, therefore, it does not like to nap. Question 10. Which of the following is the biconditional of the following conditional statement? So y'all, for a biconditional, I know I have to do two things because bi means two. Well, that didn't turn out very good. Let's try again. Let's see, maybe I was too close to the edge. I don't know. All right, so bi means two. I have to do two things. First, I have to cross out the if and the then. In the middle, I have to now insert if and only if. So the two things I had to do, cross out if and then, that was number one. And second, I had to insert if and only if in the middle. Remember, y'all, IFF is the abbreviation for if and only if. Now, we've done all the work. We just have to find the sentence that now says two angles are congruent if and only if they have the same measure. I can see right away it's not A because A still has if in the front of the sentence. That should have been crossed out. Let's check B. Two angles are congruent if and only if they have the same measure. That's a perfect match. I feel very confident my answer is B. But I need to check and make sure C and D don't also work. C, if they do not have the same measure, well, I can stop right there. That if was supposed to be crossed out. I know it isn't C. Finally, D. Two angles are congruent. That looks good. If and only if, that looks good in the middle. They do not have the same measure. Oh my goodness, y'all, they were so sneaky. They negated the second part, and they weren't supposed to change the statements. So that is not correct. It's also not D. The only correct answer for biconditional is B. Two angles are congruent if and only if they have the same measure. Question 11. Choose the counterexample that proves the following statement is false. If Tracy goes to the movies, then she will buy popcorn. Y'all, a counterexample is a very specific example that makes this statement down here be false. Counter means false. So here's what has to happen. Tracy has to go to the movies. That has to happen. When she's at the movies, she is not allowed to buy popcorn. To be a good counterexample, the hypothesis, the first part, has to be true. At the same time, the conclusion has to be false. So once again, Tracy has to be going to the movies. She cannot buy popcorn. So let's check out and see which answer says that. Tracy had popcorn while hanging out with her friends. Y'all, she can't have popcorn, so it's not A. B. Tracy did not go to the movie and she ate popcorn. Y'all, she had to go to the movies, so it's not B, because B says she did not go to the movies. All right, C. Tracy went to the movie. That's good. And bought candy, but not popcorn. That's it. The hypothesis is true that Tracy went to the movie, but the conclusion is false. She did not buy popcorn. That's the way a counterexample works. All right, but we got to check out D just to make sure that Miss Ratliff didn't mess up. Tracy went to the movie. Yep. She bought candy and popcorn. Y'all, she wasn't allowed to buy popcorn for the counterexample. So D is not correct. The only counterexample for this statement would be Tracy went to the movie and bought candy, but not popcorn. Because that proves this statement up here is false. All right, question number 12. Rewrite the following sentences in symbolic notation using P, it is a pentagon, and Q, it has 5 sides. All right, so if we see the words, it is a pentagon, we're going to replace that with P. If we see it has 5 sides, we're going to replace that statement with Q. All right, the statement is, it has 5 sides. I think that's a perfect match to Q. So in the first box, I'm going to put a Q. If and only if, y'all, I remember if I have 2 ifs, then I need 2 arrows. So I know that the middle symbol is going to be the double arrow. And let's see, it is a pentagon. That's a perfect match to P. It is a pentagon. All right, let's see if there's more, because look, these options take a lot of room. Nope, that was it. I thought there was going to be another one because it said sentences, but y'all, that's it. So we're done with this problem. All right, and let's see. Number 13. Which of the following choices is the inverse of the following statement? All right, inverse. There's a clue in there. We have to keep it in the original order, but we have to negate each part. Here's my little symbol for negate. Now, y'all, you got to remember, negate means if it already had a knot, you take it out. If it didn't already have a knot, you're going to put one in. All right, so let's see. If it doesn't snow, that already had the knot in there. So when we negate it, we take it out. We'll go ahead and cross that out. The knot goes away. Then we will have school. If I negate that, it would be then we will not have school. You keep it in order, but negate each part. All right, so let's see. If it does snow, then we will not have school. I think that's A. If it snows, then we won't have school. All right, you got to check out the rest though. All right, if we have school, well, y'all, that's the end. They switched it. For inverse, you do not switch it. If we don't have school, y'all, that's switched as well because having school was supposed to stay at the end. It doesn't snow if and only if we have school. All right, I know if I have two ifs, that's going to be biconditional. They want the inverse. I know I saw inverse up there somewhere. This is the biconditional, so it's not D. The inverse would be A. If it snows, then we won't have school. And that's the end. Hopefully you feel more confident with the material from unit 1, logic and reasoning. If you still need additional help, let Miss Ratliff or Miss O'Dell know.